So this is a continuation of previous two video, part 1, part 2 of logistic regression. Yi already defined is y is a response variable already defined, that is for ith observation 1 if with probability pi I, 0 with probability 1 minus pi I. We already observed three things. First, we cannot assume epsilon I, that is ith error component, follow normal 0 sigma square, because we see when yi take two values either 1 or 0, then when yi equal to 1, then epsilon I takes 1 minus xi curl prime beta curl, where xi curl equal to 1. This is correspond intercept term xi1 xik, since we considered k explanatory variables, and beta curl equal to beta naught beta 1 beta k prime, and when yi equal to 0, then xi takes epsilon takes minus xi curl prime beta curl when yi equal to 0. So we cannot assume epsilon follow normal 0 sigma square. Next thing we observed, variance of yi equal to pi I 1 minus pi I. So this is the violation of homoscedastic assumption. And third thing, expectation yi, which is equal to pi I, this is nothing but a probability of yi equal to 1 lies between 0 to 1. So this is also we observed. So this implies we cannot fit a model in which the predicted values lies outside the interval 0 to 1. So these three things we observed. So expectation of yi is not equal to xi curl prime beta curl. Why? Because this part is a systematic component of expectation of y, which is called linear predictor, and this is unbounded. That is, this is lies between minus infinity to plus infinity. And again, this part is lies between 0 to 1. So we cannot write expectation of yi equal to xi curl prime beta curl. So for this reason we need a link function which link these two parts. And in our part 2 video we see that for logistic regression, or when the response are binary variable, then the appropriate link function is eta log, suppose for this is ith response, log pi I 1 minus pi I, where eta is nothing but a xi curl prime beta curl. And this is called logic transformation. And now we see that this value lies between minus infinity to plus infinity. Now the next issue is how to interpret the parameters. So for this, first we consider an example. Suppose we consider a sample of 200 students in a university and take two observations from each student. First observation corresponding ith student, that is yi, which is our response variable or outcome variable, defined as 1 if ith student is an honors class, and 0 if ith student is not an honors class. And another part is xi, that is explanatory variable, math score of ith student. So first we take a sample of 200 students, and from each student we take two observations. One is response variable, that is 1 if the ith student is an honors class, and 0 if ith student is not an honors class. And another part is, that is the math score of ith student. So we have (200) paired observation. Using this data set, if we feed the model, logistic model, then we get this is the predicted log odds ratio, log odds for ith student, then we get beta naught hat equal to and beta 1 hat equal to So what is the meaning of minus 9.79? Now if we see that when xi equal to 0 or x is equal to 0, that means when the math score is 0, then log pi hat 1 minus pi hat equal to minus 9.79. So this is equal to pi hat by 1 minus pi hat equal to approximately 0. So these odds are very low. Now if we look at the data set or the distribution of math score, we see that no one in the sample has math score lower than 30. That is, there are no observations whose math score or no students whose math score less than 30. Moreover, we have seen that the mean math score is 50 and standard deviation approximately 10. Hence, here beta naught has no real interpretation. So the intercept, that is beta naught, in this model corresponds to the log odds of being an honors class when math is at the hypothetical value of 0. So this is corresponds to the log odds, that is the pi hat by 1 minus pi hat, estimate of log odds pi hat by 1 minus pi hat of being in an honors class when math is at the hypothetical value of 0. Now suppose we consider x is equal to 54. Suppose a student who scored math score is 54, then log pi hat 1 minus pi hat corresponding to the student whose math score is 54 is equal to minus 9.79 plus into 54. Then we consider another student whose math score is 55, say. Then estimate of log odds corresponding math score 55 is equal to minus 9.79 plus 0.16 into 55. Now one minus 2 is equal to log odds corresponding x is equal to 55 minus log odds corresponding 54 is equal to 0.16. Then this is nothing but a log odds ratio and see that this ratio is equal to exp approximately equal to 1.7. Hence, you can say that for 1 unit increase in math score we expect to see about 17% increase in the odds of being in an honors class. So this is the interpretation of beta naught hat and beta 1 hat. And moreover, here I mentioned that so this value does not depend on the value of x. So this is generally true. So for 1 unit increase in math score, so you can say this generally, for 1 unit increase in math score, we expect to see about 17% increase in the odds of being in an honors class. So in generally, suppose our eta hat xi, first we consider the case one explanatory variable. So for this situation, at x is equal to xi, eta hat xi equal to beta naught hat beta 1 xi, eta hat xi plus 1, if you increase 1 unit, then eta hat xi plus 1 equal to beta naught hat plus beta 1 hat xi plus 1. Then subtract this from this, then we get eta hat xi plus 1 equal to log odds xi plus 1 minus log odds xi. This is equal to log odds xi plus 1 by odds xi. So this implies odds xi plus 1 odds xi equal to exp beta 1 hat. This is termed as odds ratio. This is termed as odd ratio. when value of explanatory variable changes by 1 unit. When there are more than one explanatory variables, then the interpretation of beta j's is similar as in the case of single explanatory variable. The odd ratio is beta j hat associated with explanatory variable xj, keeping other explanatory variables constant. So again I repeat this thing. The odd ratio is exp beta j hat associated with explanatory variable xj, keeping other explanatory variables constant. This is similar to the interpretation of beta j in multiple linear regression model. If there is a m unit change in the explanatory variable, then the estimated increase in odd ratio is exp m beta j hat. Again I repeat this thing. If there is a m unit change in the explanatory variable, then the estimated increase in odds ratio is exp m beta j hat. So please stay with us. We continue this topic, logistic regression, in our next video.